Welcome, algebra students of all ages. We're going to be talking about section 4.4, multiplying polynomials. We introduced polynomials in the previous sections, I think either 4.3 or 4.2, but now we're going to be fleshing out how do we multiply them. So let's go ahead and get into that. Not as bad as you think. You guys have probably heard about some of these before, but let's go ahead and flesh it out a little bit. So monomials. If we're going to multiply two monomials together, fairly simple process, but we start by multiplying the numerical what? We multiply the numerical coefficients. Always start with the numbers. Those are the kind of the easiest ones to do. So you can see that we have coefficients there and there, okay? This is a monomial, okay, one term, and then we have this is a monomial, that's one term, and we're going to multiply them together. And then what we do is we multiply like bases. So here we have like bases with the x and the x, like bases. Now what do we do with that? We're going to add the exponents of like bases. Okay, and the reason why we do that is because we have to remember the properties of exponents. We have to apply those rules, okay? Now, what happens when we do that? Well, we do 3 times 5, and that gives us 15. And then we have x to the 4th times x squared. That's going to give us x to the 7th because we added the exponents together. So that is going to be our final answer. What about something like this? Same deal. We're going to multiply the coefficients in front, the numbers. So we have 2 times 8, that gives us 16. Now we're going to look for like bases. We have m, we have y, and actually that's the only y, and then we have z and z. So we're going to start with m. We have like bases. We're going to add the exponents, so we have 2 plus 3. That's m to the 5th power. We have our y. We're going to go in numerical order. We have our y next, and he's not multiplied by anybody. That's technically y to the 1st, but it's an implied one just by writing y. And then we have z to the 4th times z to the 2nd. That's our product rule. We're going to get z to the 6th power, z to the 6th power. And that's going to be our final answer. Monomials, fairly easy. That's the process. Multiplying binomials. Okay, how do we do this? Well, a lot of times we're going to use the distributive property, and then we're going to combine like terms. So remember, binomials means 2 terms. 2 terms. Monomial, 1 term. So now what we're going to do is we're going to use the distributive property. Boom, boom. Okay, we have parentheses. We're going to multiply this number out in front. So we have negative 2 times x to the 3rd. This one's fairly easy because you'll notice this has no x there. So we just multiply the numbers out in front and then multiply the numbers out in front with both those terms. So you have negative 2 times 8 gives us negative 16. Because there's no variables, we're going to keep it as x to the 3rd. Then we have negative 2 times negative 9. That's how I like to think of it. I like to think of it as a negative 9. And then it gives us positive 18. There's no variables, so we're going to leave it as x squared. Notice how at this point, this stage in the game, we do not combine these. Why? You said before when we multiply them, we add the exponents. Well, guess what? We're not multiplying them now. Now we're adding different coefficients, different bases. These are different terms, so we cannot combine them together. They are unlike terms because there's addition or subtraction. It's not multiplication. There's a big difference there. Keep that in mind. Do not combine that to be negative or positive 2x to the 5th. Don't do that, okay? So we're going to apply the same thing here. We're just going to distribute. This time we're going to have to worry about the x. First, we're going to multiply all these coefficients together. So we're going to get 5 times negative 4 gives us negative 20. And before I get to the next term, actually, I want to handle the x's because that's something we need to consider this time. What we have going on here is we have 5x squared times negative 4x squared. I want you to see the difference between this plus and this times. Now that it's times, we are going to add exponents because of the multiplication. So we're going to have x to the 4th power. Okay. Now we're moving on to the next one. So we're done with this guy. Done. Now we're moving on to the second rainbow, the second distribution. And we get 15, and it's positive. So positive 15. Then we have these two x's together. Okay. There's an implied 1 there. So we're going to add exponents, and we get x to the third. We add exponents. Final step, we get minus 2 times positive 5, and that gives us minus 10. Where's my color? Pink. There it is. Minus 10. There's only that x squared. There's no other thing that we're multiplying by, so I'm going to leave it purple. X squared, and there we go. There's our answer. We can't combine it from here, because guess what? It's addition, subtraction between, and they're not like terms. Okay? All right, here we go. I'm sure you guys have seen this before, and I'm sure you come up with a certain name. What do we do here? Well, what I like to consider is essentially we do distribution twice. If it was just 3 times x plus 5, you would know what to do. You just distribute, and you get 3x plus 15. Okay? That distribution you would get. Now, what about this distribution? Would you get a problem like this? X times x plus 5? Yeah, for sure you would get that. You would just... Let me go this way, actually. Okay, you would get x squared. X times x is x squared, plus 5 times x is 5x. You would get that, okay? So we distribute in the with a 3, you get that. We distribute with the x, you get that. Now we just have to do both, okay? Because there's parentheses here and parentheses, 2 sets of parentheses, we have to do 2 sets of distribution. And I'm sure a lot of you call this FOIL, which I'm going to get to in a second. Don't spoil it. Okay, I know you're thinking it. Don't spoil it yet. Just wait. Be patient. And then we distribute this guy. I like to demonstrate it visually like this. I think that's the easiest way to do it. You connect arrows with a 3 to both terms in the second parentheses, and you connect the x with both terms in the second parentheses also. Once you do that, we get this result down here, as I've already done. And your final, not answer, but final outcome is going to be 3x plus 15 plus x squared plus 5x. It's a plus because that's an implied positive. There's nothing written there. Now, we're combining like terms. You're always going to have like terms here when you have 2 binomials. This is multiplying 2 binomials. Okay, you're always going to have like terms here. So we're going to write it in descending order, standard form, x squared plus, look, we have like terms, 8x plus 15. It becomes a trinomial, 3 terms, and there we go. There's our final answer. Now what happens when we get this scenario? We have a couple options. You could distribute this first to that guy, or you could distribute this first to that guy, and then you could go from there. But in my opinion, I think it's easier to handle this parenthesis first, okay, and then multiply this when you're done. Up to you, really. It's like choose your own adventure. I love those books, but this one we can do in that way. So what I'm going to do here is I'm going to show that we're going to multiply this times this. Okay, I'm going to do this multiplication first in green. This times this. Okay, the x times both terms, the negative 7 times both. I don't know why I gave the second term priority, but whatever. We'll start with the bottom. Okay, just like Drake. So we do x times x gives us x squared. I'm starting with the bottom arrows. And then we have x times 4 gives me positive 4x. Now I'm on to negative 7 times x. That gives me negative 7x. And then negative 7 times 4 gives me negative 28. All right. Combine like terms. Where do I have like terms? You're wondering, or maybe you're not wondering. Maybe you see it. Well, if you see it, you'll see this. X squared minus 3x minus 28. Are we done? No, we forgot the purple. We forgot the purple. So we're going to move this guy over. That was the result of that. Let's get our purple parentheses back out. He's back in the game, and we have 2x squared now. This is kind of similar to what we did up here with the monomials, but all we're doing here is multiplying this times this times this, and this times this, okay? Fairly simple. We just have to make sure we're doing, keeping track of our like bases. We're going to have lots of like bases here. The 28, he's kind of a loner, but we're going to have lots of like bases. Be careful with that. So we have 2x to the 4th, add the exponents, minus 6x to the 3rd, minus, what is that, 56? 56. X squared, don't forget the x squared. And there you go. It's written in descending order, and we're done. There's another way to consider this. Again, you can do what I like to do, which is draw the arrows, okay, to both in the second parentheses and you'll be square every time you do that. Another way to do it is you'll see Khan Academies on this. You'll see your teachers try to demonstrate this. I think it's okay. I think it's a little overrated, but if your teacher says this is the way you should learn it, then be nice, okay? Just try to be understanding. 5a times 3a gives you 5a squared. This is what we're doing. We're just multiplying. I don't know if you guys remember lattice or whatever when you guys were first learning multiplication, but essentially we're just multiplying these rows together like that. So we're going to do 3a times negative 2b. That gives us negative 6ab. 5a times b, okay, gives us 5ab, 5ab. And then we get negative 2 times negative 2b times b is going to give us negative 2b squared. Now we just write it, combining them all with the proper terms, minus 6ab plus 5ab. I just keep the signs in front. If you're wondering, it's like, how do you know if it's addition or subtraction? Just keep the sign in front. You're always going to have like terms when you multiply binomials. So guess what? This becomes 15a squared minus ab minus ab minus 2b squared. There's your final answer. Okay, so that's another way to see it visually. Now, the other way to consider it, I showed you that we can use distribution with it. I showed you that we can, I showed that twice, and then you can use this little grid. You can also use what's called foiling. Okay, FOIL is first, change color. I'm going to try to make this the last thing in this video. First, outside, inside, and then last. Now, this is the first term. Okay, the first term in both of them. Okay, the first term in each parentheses. The outside terms are the one that are on the outside of the parentheses. So you can, like, if you're looking at this like a house, the outsides would be here. The first terms in each parenthesis, the last term in each parenthesis, and then the inside terms, the ones that are on the inside of the house. And that was a really kind of crappy drawing, but I hope you guys get it. Inside, outside, and then first and last in the parenthesis. Okay, what a beautiful drawing. Pause it, but this thing is getting erased. Sorry. And then we have the inside. Now, what's it saying? It's saying we're going to multiply all these combinations. And I really should change the color. I can't believe, usually I change the color, make it all like color coordinate everything. We're going to do that. Okay, so hang in with me. I'm going to change these colors, style. What color's first? Blue, of course, first. Last, we'll leave it as red. But I want to make it more ugly red. Let's make it like this, kind of obnoxious. That's not red. Let's make it that. I don't want to change colors. Let's make it orange. I know it's not red. Don't yell at me, please. Style, let's make this one outside green, and then inside we'll make like a pink color. Style, pink. Okay, just so you can keep it straight. Now, what I'm going to do is I'm going to multiply the first terms together. So I have 4m times 3m. That gives me 12m squared. Then, based on the order, I did my first. Check with first. Now I'm going to do my outside terms. That's my green ones. 4m times positive 1. So I get 4m times 1, which is 4m. Okay? Outside, check. Now I'm going to go to the inside. Now my inside terms are negative 5 times 3m. I'm just going to get negative 15m there. Inside, check. And now I'm on to my last terms. Negative 5 times a positive 1 gives me negative 5. Last terms, check. Now you're always going to have some like terms, as I've been saying this whole time, and it's usually going to be the middle terms, okay? The inside and the outside terms that combine to give you fewer terms once you combine them. So we get 12m squared minus 9m minus 5, and that's going to be our answer. Now, you're probably thinking, what are all these dashes for? Well, that's because you don't have to just FOIL. We went in first, let me highlight it. We went first, outside, inside, last. You can go in a different order, and it's going to have the same outcome. You could go last, outside, inside, first. You could LOIF, last, outside, inside, first. You could LIFO. You could go last, inside, first, outside. As long as you get each one of those combinations, you're good. You could get OILIF. You could get outside, inside, last, first. I don't know. What else is there? We could go inside, last, outside, first. ILOF. Okay, all those are valid as long as you get all the combinations and keep the signs consistent between them. But most people like FOIL. They're like, oh, I just FOILed it. Okay, fine. FOIL is just another way of multiplying binomials. So this is going to be the last problem we do, and then I'm going to make sum and difference of two terms, square binomial, and that other one in a separate video, part 2. So here's our last one. I'm going to LIFO it. Yeah, I'm going to LIFO. So I'm going to go last. Oh, here, I like doing this. So last terms are negative 49. Ignore the announcement. I have negative 49. Those are the last terms. Then I'm going to go last inside, I think. Inside are plus 7p. And then my outside, I hope you guys didn't hear those, minus 7p. And then my first. That is my time is up signal. So I have p squared. These cancel out, minus 49. And this will lead us to part 2. I got alarms going off all over the place. I got to go. Bye.